Alright, so in this problem, I have 3 to the power of x is equal to 7 to the power of x plus 2. So to start, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of x plus 2, we can rewrite as 7 to the power of x times 7 to the power of 2. Now, I'm going to go ahead and divide both sides by 7 to the power of x. So then these two cancel out, and now I'm going to be left with 3 to the power of x over 7 to the power of x is equal to 7 squared. And if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 3 to the power of x over 7 to the power of x, that's equal to 3 over 7 to the power of x, which is equal to 7 squared. Now, I'm going to take the log of base 3 over 7 on both sides. So now I have log base 3 over 7 of 3 over 7 to the power of x is equal to log base 3 over 7 of 7 squared. Now, if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this can equal b times log a. So in this case, I have x as my exponent, so I can move it to the front. So then I have x times log base 3 over 7 of 3 over 7 is equal to log base 3 over 7 of, 2 times log base 3 over 7 of 7. And now, these two actually cancel out. Log base 3 over 7 of 3 over 7. So now I'm just left with x is equal to 2 times log base 3 over 7 of 7. Now, log base 3 over 7 of 7, that's the same thing as log base 7 over log base 3 over 7. So x is equal to 2 times log base 7 over log base 3 over 7. Alright, so in this problem, I have 9 to the power of x plus 9 to the power of x plus 1 is equal to 270. So what I'm first going to do is, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 9 to the power of x plus 1, I can rewrite as 9 to the power of x times 9 to the power of 1. This is equal to 270. Now, if I factor out 9 to the power of x from here, I get 9 to the power of x times 1 plus 9. Sorry, actually, instead of doing that, I'm actually going to let 9 to the power of x equal to the variable m. So now I have m plus m times 9 is equal to 270. M times 9, that's simply 9m, so I have m plus 9m is equal to 270. 9m plus m, that's 10m, so I have 10m is equal to 270, meaning m is 27. So we got the value of m, but we're actually looking for the value of x. So if 9 to the power of x is equal to 27, because m is 9 to the power of x, then I get 9 to the power of x is equal to 27. So to solve this, I'm going to rewrite 9 here as 3 squared. So now I have 3 squared to the power of x is equal to 27. Now I'm going to rewrite as 3 to the power of 3. And if I have something in the form a to the power of m to the power of n. This is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2x, which is equal to 3. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, n is 1. So I have 2x is equal to 1, meaning x is equal to 1/2. Sorry, this isn't 3 to the power of 1. This is 3 to the power of 3. So 2x is equal to 3, so x is 3 over 2, not 1/2. Now to check, I had 9 to the power of x plus 9 to the power of x plus 1 is equal to 270. So x is 3 over 2, so I have 9 to the power of 3 over 2 plus 9 to the power of 3 over 2 plus 1 is equal to 270. And this is the same thing as 9 to the power of 3 over 2 plus 9 to the power of 5 over 2 is equal to 270. Now, 9 is the same thing as 3 squared, so I have 3 squared to the power of 3 over 2 plus 3 squared to the power of 5 over 2 is equal to 270. These 2's cancel out, these 2's cancel out, so now I have 3 to the power of 3 plus 3 to the power of 5 is equal to 270. Now, 3 to the power of 3 is 27, and 3 to the power of 5 is 243. And 27 plus 243 is 270. So 270 equals 270. Alright, so in this problem, I have 0.2 to the power of x is equal to 2. So for this problem, I want to find the value of x. So for my solution, first start with 0.2 to the power of x is equal to 2. Now I'm going to take the log on both sides. So I have log 0.2 to the power of x is equal to log 2. And if I have something in the form log a to the power of b, I can actually move this exponent b here to the front. So this can equal b times log a. So in this case, I have log 0.2 to the power of x, and I can move x to the front. So now I have x times log 0.2 is equal to log 2. Now if I divide both sides by log 0.2, these two cancel out, and I get x is equal to log 2 over log 0.2. Now, if you notice here, log 0.2, well, that's the same thing as log of 2 over 10. And if I have something in the form log a over b, this is simply equal to log a minus log b. So in this case, a is 2 and b is 10. So I can rewrite this as x is equal to log 2 over log 2 minus log 10. Now, log 10, as we all know, is simply 1. So I have x is equal to log 2 over log 2 minus 1. Now, log 2, this is equal to 0.3010. So I have 0.3010 over 0.3010 minus 1. And now this is equal to 0.3010 over 0.6990. And finally, if I divide these two, I get that x is equal to, sorry, this is actually negative 0.6990. X is equal to negative 0.43.